So we've seen one algorithm for multiplication, but it's not the standard algorithm. Let's see what the standard algorithm for multiplication looks like. And first, we're going to just see the standard algorithm for multiplying a multi-digit number by a single-digit number. So suppose we want to multiply 3,118 times 7. To set up the standard algorithm, we'll write 3,118 times 7. And I'm going to work the same problem in the area model just so you can see what's going on. Now notice that each of the diagonals in this box, when I'm multiplying by a single-digit number, has only 2 entries, except for the first and last, which have 1 each. And the 2 entries are the digit with the larger place value from the previous place and the digit with the lower place value from this place. So when we first multiply 7 times 8, 7 times 8 is 56. We put a 5 in the tens place and a 6 in the ones place. What we're going to do in the standard algorithm, we now know that the ones place of our answer is going to be a 6. And we'll need to carry a 5. Right, 5 will carry over to participate in the tens place of our answer. Now we multiply 1 times 7. Well, we know what that is. 1 times anything is the thing itself. So that's just 7. Now what are we going to do over here? Right, so we had the 6 in the ones place. Over here we're ready to fill in the tens place. Right? 5 plus 7, that's 12. Right, so we'll carry the 1 and write down the 2. Over here we'll multiply 7 times 1 is 7. Add in the 5 we carried and we get 12. So we'll carry a 1 and write down the 2. Alright, so here again, 1 times 7 is 7. We take the 7 plus the 0 from the previous number plus the 1 that we carried, and we get 8. Over here we take 7 times 1 is 7, add the 1 we carried, and we get 8. Over here we take 3 times 7 is 21. We take the 1 plus, well, this was a 0, so just 1. And we carry the 2 over into the next place, but we're already done with the next place, so this is 2. Over here we have 7 times 3 is still 21, and we just put down the 21. Either way we get 21,826 for our product. Let's see another example where things mix a little bit more. Suppose we want to multiply 429 times 8. So we multiply 8 times 9 is 72. Here I write down 72. Here I write down 2 and carry the 7. Next place, I'm going to multiply 8 times 2. 8 times 2 is 16. Here I write down 16. I'm sorry, I'm going to fill in the places also as we go. And then I'm going to add 7 plus 6 and get 13, right? So I'll carry the 1 and write down the 3. What happens over here? I multiply 8 times 2 is 16, and then I add the 7 that I carried. 16, 17, 18, 19, 20, 21, 22, 23. So I'm going to write down the 3 and carry the 2. Right, so over here I have a 1 and an additional 1 that I carried. Here I just carried a 2. That accomplishes the same thing. All right, so now I have 8 times 4 is 32. And so I'll have 1 plus 1 is 2, plus 2 is 4. And then the 3 is by itself. 8 times 4 is still 32. 33, 34. Here I just have 34. Either way, again, my product is 3,432. So what's going on? Let's take a look at the standard algorithm just on its own merits. We'll multiply 8,263 times 6. The first thing I notice about the standard algorithm, a thing that I like, is I'm only ever going to be multiplying by 6. So I can just put a ruler down on the 6 row in my table if I'd like. So I'll have 6 times 3, right? This is 6 ones times 3 ones. 6 times 3 is 18. Carry the 1, write down the 8. So I have 110 sitting around up here. Then I have 6 times 6 tens. Right, this 6 doesn't just represent 6. It is 6 tens. So 6 times 6 is 36. That gives me 36 tens, plus the one that I carried for 37 tens. 37 tens, that's 7 tens and 3 hundreds. Right. This 2 doesn't just represent 2, it's 2 hundreds. So when I say 6 times 2 is 12, that's 12 hundreds. Add in the 3 hundreds that I carried, that's 13, 14, 15 hundreds. 15 hundreds, that's 5 hundreds, carry 1 thousands. Now this 8 over here represents 8 thousands. So when I multiply 6 times 8, it's 48. That means I have 48 thousands. Add in the 1 that I carried, that's 49 thousands. My product is 49,578. So what do we notice? The first thing we notice is that carried numbers are added, right? They aren't multiplied in. That doesn't make sense. And the second thing we notice is, at each step, we write exactly 1 digit and maybe carry to the next digit. Right, so just like with addition and subtraction, the action is happening only in one place at any given time. We work out the single digit product, maybe add in a carry, and then we're on to the next place value. Now, do I think super carefully about place value the whole time I'm doing a problem like this? No, I let the number system do the work for me. I'm going to show you one more example, and I'm going to narrate what I'm thinking when I work a problem like this. I'm going to multiply 429 times 4. And again, I can just put a ruler down on the 4 row in my multiplication table. So 4 times 9 is 36. Carry the 3, write down the 6. 4 times 2 is 8. 9, 10, 11. Carry the 1, write down the 1. 4 times 4 is 16. Plus 1 is 17. Notice I didn't think about carrying in the leftmost place because there was nothing beyond that to deal with. I'm going to give you one of these to try now. 3,138 times 7. Try multiplying this. Again, use this technique. Try multiplying this using the standard algorithm. Pause the video and try it now. Okay, what do we have? We have 3,138 times 7. I'm going to put the ruler over the sevens row. 7 times 8 is 56. Carry the 5. 7 times 3 is 21. 22, 23, 24, 25, 26. Carry the 2, write down the 6. 7 times 1 is 7, plus 2 is 9. 7 times 3 is 21. So my product is 21,966.